Welcome to Honey of Knowledge. This is Ashish Gourav, and today we will be talking about a new kind of an equilibrium concept, blockchain Nash equilibrium. Now, this Nash equilibrium, or rather equilibrium concept, is used in smart contracts. So, before we go to the equilibrium concept, let's just see the normal scenario when we do not have that smart contract. We just have the normal strategic interaction happening there. So, in our current situation, we have two companies, company A and company B. Both the company can choose to share some kind of a strategic information which is crucial for the business. And if they share that information, they gain mutually. And if they do not share that information, they would be at a disadvantage. Now, this is the payoff matrix of that interaction. If both of them share the information, they take 9 units of utility each. And if one of the company shares information and the other company chooses not to share information, the company who is choosing not to share the information can benefit by a bigger margin. Something like 18 to the company who chooses not to share and 0 to the company who shares information. And if they don't share, then obviously the whole ecosystem of these companies is lacking in key information. So they would have a substandard kind of an outcome. So now let's run through the Nash equilibrium very quickly. Now, if you observe 6,6 don't share is the Nash equilibrium, and it's even the dominant strategy for both the companies. Let's understand why. If supposedly you are on this cell, company A can either choose not to share or it can choose to share. But why would the company go from 6 to 0? So company A would not choose this. So it will not share. Similarly, if you look at company B, it can take 6 by not sharing and take 0 by sharing. So even company B would not shift here. So this is a Nash equilibrium because there is no unilateral deviation possible, which is profitable in nature. Now, how do we get to this Nash equilibrium? So I'll just give you a quick method to finding it out if you're not familiar with the solution. What we do is we put star. Let's look at for company A. For company A, if company B is sharing the information, it can choose to either share information or choose to not share. So it can take either 9 or 18. So obviously it will take 18. So I put a star on 18. Now for company A, if company B is choosing not to share, company A has to choose between 0 and 6. So it will choose between 6. So you can see that don't share or no sharing of information, key information I mean, is a dominant strategy for company A. And if you look at the payoff matrix, this is kind of symmetric in nature. So if you do the same exercise for company B, you would find that even company B has the same dominant strategy. So they would land up and you would get a star here and here. So double star is a Nash equilibrium. This is a shortcut to finding Nash equilibrium. So this outcome is obviously not desirable for the whole ecosystem. If both of them shared information, they could have taken 9 plus 9, 18. But now they're taking 6 plus 6, which is 12. So there is a loss of 6. Now this loss of 6 can be avoided if we use smart contracts based on blockchain technology. Let's see how. I have abbreviated sharing information by S and not sharing information, key information, by NS, and we are using a smart contract, if and only if contract, IFF contract, using blockchain technology, which means that I have some kind of a way to enforce a contract such that I only take a specific action dependent on what other party is doing. So it is kind of making a simultaneous move game to a sequential move game, but not in the real sense of sequential move game. We're just trying to manipulate this using blockchain technology. So let's understand what's the idea here. So this contract is saying that if company A chooses to share information, and the if clause of the contract will say I'll also share the information. If company A chooses not to share the information, if contract says I'll also choose not to share the information. So what happens is whenever company A chooses the share decision or share choice, the if clause makes me share information, and if company A is choosing not to share, the if clause is making me not to share. So you can see that share is replicated here, and not share is replicated here, and similarly you can see it here also and here also, because this is kind of a symmetric payoff matrix. Now if you try to find out the Nash equilibrium here, you will get one extra Nash equilibrium, which is this 9,9. Now how do we calculate this? Let's run through this very quickly. Again we'll use the star method. So for the row player, this is the row player, right? So the row player decides for every column, and the column player decides for every row. You might find it quite counterintuitive, but think about it. The row player sees what the column player is doing. Either it is choosing this column, or this column. Now after the column player has chosen a column, the row player needs to make a choice on the row. But the idea here is I need to choose a row, but along a column. That's the key idea. Row player chooses a row along a column. That is why for row player we need to look at the columns, and for the column player we need to look at the rows. So for the row player, for this column, obviously this is the highest. For this column I have a tie. For this column I again have a tie. For the column player will take rows into consideration. For this row, this is the highest. For this row I have a tie. For this row I again have a tie. So you can see there are two Nash equilibria. The earlier one without the if and only if contract, and the new Nash equilibrium with the smart contract or if and only if contract. Now blockchain technology is giving you this new Nash equilibrium. Now what is the advantage of this? Because of if and only if contract, I am getting a social surplus of 18, and the earlier social surplus was 12. Now I might do a video explaining the idea of social surplus, but to make it more simple, I would just say that in a community the total utility is social surplus. So in this community we have two companies. So we just add the utilities, 18 here and 12 here. So we have a gain of 6 utils or 6 units of utility because of the if and only if contract or the smart contract using blockchain technology. So blockchain is quite important to get these kind of contracts implemented, which is not possible without the blockchain technology because of commitment issues. So I'll be doing more videos on blockchain. So keep watching the space, and don't forget to like, share and subscribe. Hit that red button. Bye.